Mike from Digital Offensive, and you're watching my path to GXPN. So let me give you a quick update of where I'm at with the GXPN. So I have about 14 days left before my exam, and today I took my first practice test, and in that practice test I scored a 76. There was a few areas that I know that I totally second-guessed myself and screwed up, but there was definitely many areas that I had no idea about, which means I need to go back and do some additional studying. My current goal is to start rereading the books, building a better index, and then take my second practice test by next Wednesday. That'll give me 24 to 48 hours to decide if I'm going to cancel and extend my time to take my exam, or take a shot at the exam and risk not passing it, which would cost me quite a bit of additional money to retake it again. I feel pretty confident in a lot of areas, but there's still areas where I am totally lost at, such as with the assembly language and moving stuff around in the stack. With that being said, today's video, I want to bring you a little bit of exploit development to the channel today. And I mentioned about doing stuff like this in the past. I just haven't really had the time to do it. So in this video, we're going to take a look back at our old friend Brainpan. Now, if you remember Brainpan, or if you have watched my previous videos, Brainpan is a vuln hub machine. It's a boot to root that basically allows you to gain the initial foothold on the box through a buffer overflow. Now, you can download the code and write your own buffer overflow. And if you're interested in learning that, you can watch my other Brainpan video. And I go through how to actually develop the whole buffer overflow from start to finish, how to find it, how to build it, and then how to exploit it. What I want to cover in this video, however, is how to take that Python code we wrote and weaponize it, put it into Metasploit, so you have a point-click exploit moving forward with Brainpan. And that's what we're going to do today. We're going to basically build our own Metasploit module out of the Brainpan source code, and then we can use it inside of Metasploit for future exploiting. Now, is there real value in this? Not in the sense of using Brainpan's code, but there is value in this of learning how to build a Metasploit module. There's a couple of videos out there how to do this, and some of them are a little older, some of them are not as clear. I want to try to break it down in the most simplest terms for you guys today. Okay, so welcome back, guys. This is actually the second day I'm trying to record this video, so hence the different clothing. But either way, let's get into our original Python script. So our original Python script that we wrote, and as I said earlier, if you want to see the original way we got this code, check out my Brainpan video on how to develop the buffer overflow. I'll link that in the description below. However, let's take a look at the actual code that we did write. So it's a simple Python script. We're importing the socket library, and that's going to allow us to build a TCP socket to make these connections. And then here we're basically defining the socket. So we're assigning the value of S to the actual creation of the socket. And then we're coming down here and defining our buffer. This is the data we're going to send to the victim. And in this case, we're starting off right here with our shellcode. And our shellcode here is basically a MS Venom output, where I basically define to use the Linux interpreter reverse TCP shell, as well as defining my IP address and my port number. Now, the one problem with this method that I used here is if my IP changes or that ports in use, my shellcode won't work and I'll need to modify it. This is kind of bad if I'm traveling and I'm trying to exploit things on the fly, that I need to go back into the code and modify that. Now, this case is a very simplistic case. I can just basically rerun MS Venom and recreate my payload. But in a more complex script, it may take additional time to do. And we don't want to be wasting that time. Next line down here, after the shellcode, we're defining the full buffer here. So we're saying create a buffer, the variable buffer, and that variable buffer is going to store 524 A's, so basically x41 524 times, plus the return address, so our return pointer here, plus an op sled of 20, plus our shellcode above. So basically, this is going to overflow the buffer until it hits the EIP address, putting this into EIP. This address in EIP will then redirect us over to our NOPs. And our NOPs are basically no no opcode. So basically, it's not going to do any type of code within the application. It's just going to basically slide down the stack until it finds our shellcode and executes our shellcode. Overriding our code, our shellcode, or causing problems with our shellcode, we're basically making sure that we have enough room in that stack that we're able to successfully execute our shellcode. And this is all just basic Stack Overflow. We're not talking any advanced options out there, such as DEP, ASLR, or anything like that. Just as a basic Stack Overflow. So we're basically pushing further down into the stack and then executing our shellcode. After that, we're basically going to have a fix up here. So we're going to say try this. If this fails, then basically catch the exception and tell us why. But we're going to send a message to the screen that says sending malicious buffer, just to tell you that the Python's code is doing something. Then we're going to make that connection. So we're going to use our socket here, and we're going to do sconnect. So we're going to use the function connect to the IP address of Brainpan. Now this IP address will change based on your settings. So this is another section of the Python code that you would need to change if Brainpan was a real world vulnerability and you were going to go exploit. You would need to modify that address in the script here, or rewrite the script to take argument values from the command line to avoid hard coding it into the Python script. And then we're defining the port as 9999, which is what Brainpan's using for its vulnerable buffer overflow. From there, we're now going to use the socket again to use the send function to send the buffer plus a return. So now we're going to send all this data out over the wire to Brainpan, which then will crash Brainpan and launch our shellcode if successful. If it fails, we'll get could not connect to Brainpan service. So we know this works, right? We did this in the previous lab or the previous video, and it works fine. But let's actually go through it and see all the steps involved. So first, we identified the buffer overflow. We created our exploit script. Now we're going to set up our handler, and then we're going to run our code. This code requires a handler because we're using Meterpreter. If we were using Meterpreter in just a simple reverse shell, we can just use like netcat. So let's save this script. Now that script's saved, let's jump over here to my Metasploit. And I'm going to do use exploit multi-handler. And we're going to set our payload to Linux x86 Meterpreter versus TCP. Set L port to 443. Now, you know me by now, like using 443 or common ports to help circumvent other control factors, firewalls, IPS devices, so on and so forth. Let's set our L host, and that's 192.168.1.40, excuse me. So now we have our L host set. Now we should be able to type in exploit here, and now we have our listener running. Now we're basically going to come back over here. We're going to type in Python brainpan.py. Brainpan.py. And I'm going to open one more window here because I want to show you guys what we're going to see go across the wire. So we're going to do a TCP dump -I E0 host 192.168.1.32 and port 9999. And I want to do -bx. So basically, I want to do very verbose, and I want to show additional information here. So let's get this listening. So that's running. Our handler is running, and now we're going to run the exploit. Setting malicious buffer overflowed, right? We got our Meterpreter session. If we do host name, we're on Brainpan. ID should be puck. Yep, it's puck. Now let's look at the buffer, the actual TCP. So if we come up here, we can see the actual connection over to Brainpan, and Brainpan gives you this banner that actually says Brainpan, and it says welcome to Brainpan, enter your password. And what we're doing is we're overflowing that password field of Brainpan with our attack, our buffer overflow. So here you can see all the A's we sent. And then down here, you would basically start seeing our NOP sled. So here's our 90s. And after our NOP sled, this becomes our shellcode. This is the Meterpreter shellcode from here down. And then basically that launches our reverse shell, and now we're connected. So you see how that works, right? Now, we're talking about weaponizing this. We're talking about taking this out of a Python script and moving into Metasploit. And the simplest way to do this, right? Now, I'm no professional in exporting payloads into Metasploit. I do have some knowledge about doing it. Is the way I'm going to show you 100% right? No, but it works and gives you guys a good understanding of how to do this yourself and areas you can test out yourself to learn more about doing this type of stuff if you're interested in this. So let's reset this, right? We're going to leave our TCP dump running. We're going to exit out of this. Terminate that, right? And okay, let's come back to the screen. Let's type in clear here. VI. So before we get into the code, let's look at this. Metasploit has this awesome wiki page. If you go out to their GitHub page, Rapid7 Metasploit Framework wiki, how to get started with writing an exploit is the article. Goes into a really detailed description about how to lay out your exploit, to think about the process, to make it as simplistic as possible to develop your proof of concept. Down here is where it really gets into the meat and potatoes of it. So they provide you a template. This template is awesome. They also provide you a link over to the API documentation and code examples. Both of those are very helpful as well while you're developing exploits. So you understand how Metasploit works. You need to understand the Ruby language slightly. It was easy to port over from Python to Ruby. It wasn't that hard to do. So if you have an understanding of Python or other languages and you can look through their sample documentation, you can easily write one yourself. So basically how I started off is I copied this template over to my machine and then I modified the template. Now there's a lot of information here that you may not understand. The thing about that is if you scroll down, it basically tells you exactly what needs to be filled in. Now where it gets a little confusing is when we get down to the payload section. And then basically when you're defining your exploit itself, because there's no explanation on how to define your exploit because it's your exploit, right? At that point, it's kind of your free programming, your freestyling there. So let's jump over to my screen here and walk through this. So we're going to do VI Brainpan 2, and we're going to start at the top here. And I'm going to show you the areas that I modified to get this to work. So the first line here that we added that's not in the original script is include MSF exploit remote TCP. This is including the libraries to make a remote TCP connection work. Without that, you're not able to send your packets. So that is the first option I enabled, or I included in my script. Then if we look at their sample file, we modified the following fields as name. I used the Super Kojiman, and I'm sorry if I'm pronouncing it wrong. This is the creator of the original Brainpan. I gave it the name Brainpan, called it pwn to own, and remote buffer overflow. That's all in the name of this vulnerability, of this script signature, whatever you want to call it, the module within Metasploit that we're going to put in there. The description of this. The Brainpan servers on port 9999 is vulnerable to a buffer overflow due to poor coding, right? When we looked at the original Brainpan, we saw that they were talking about static code analysis and other type of coding practices. Kind of why I put in there due to poor coding, right? Just a little play on the whole Brainpan situation. Further down, we have license is MSF license. I left that as is, did not modify that field. The author, I put my name and my tag, or my handle as you call it. References, this is a good place to put any like CVE information, Microsoft blog posts, any other information that can help people understand this vulnerability more. There's nothing really documented about Brainpan, so I just kind of left that blank. I did provide a URL over to my blog because I'm going to basically upload this code to my blog so people watching this video can go out there and download it. Platform is Linux because we are attacking the Linux box. Targets is where we would define, let's say like we had service pack levels like Windows XP, SP 1, 2, 3, so on and so forth. We can define an array of targets here. We don't have an array of targets. We can also provide additional information here. So right here we have our return address. This is where we basically want the EIP to point to. So here's the return address. In our Python code, you saw it in Little Indian format. Basically, it's in reverse for Little Indian. Payloads is the section that was a little confusing with their documentation, and I kind of used the bare minimum here, and I defined a lot more of my stuff down below. So payloads, there was a lot of options you can use. Definitely check out that wiki page about other options. I used the base option of bad characters, basically saying don't use any characters within my shellcode that are null bytes, because null bytes will terminate the shellcode and cause problems where your shell will never launch. For the define check or the check function, I didn't put a check function in, and basically what a check function does is Metasploit provides you the ability to use the Metasploit framework to test if an exploit would be actually, if a system is actually exploitable. It'll run a test to see and then come back before actually exploiting to tell you yay or nay. It's not always 100% accurate. I don't know too many payloads or too many exploits that actually have that functionality. A lot of the official ones do, but a lot of the ones that are developed by third parties, you don't see that often. Then finally, we get into the meat and the potatoes of this is around the actual exploit itself. And this is why you guys are probably all watching this, if you're still watching. But we're going to define our exploit. So we're going to do a print status. And what this print status is going to do, is going to print out to the screen the message exploiting Brainpan, right? So basically, we know the script's running. We're going to define a random text of alpha characters of 524 bytes. And the reason we're doing this, right? We can do A's, we can do B's, we can do C's, we can do any letter we want. We just got to fill that buffer out. And the reason I didn't do A's, B's, C's, things like that, which you see in a lot of these buffer overflow videos, is IPS and IDS devices, antivirus, things like that are looking for those characters. Those are known attack vectors. So if I'm using random alpha characters to fill my buffer up, I'm not hitting any special characters. I'm not hitting any numbers that basically create a issue with my assembly or my opcodes. I'm just using random letters as if I was doing almost like a pattern create to find the original buffer overflow. Like just like how Metasploit will use pattern create to create a unique pattern string. I'll kind of do the same thing here, but using that as my buffer to get to that point. This makes it harder for detection of the exploit because it's kind of hiding that data. It's not using a well-known thing. Now, I say we're doing that to try to hide our data, but then down here you can see I'm using a NOP sled. NOP sleds will also give it away as well. As you get more into exploit development, there are other assembly languages, opcodes you can use other than X90 to basically get your sled working. That's a little bit more advanced, and maybe in a future video I'll talk about that a little bit more, but not in this one. So we're using our random alpha letters. We're defining our buffer, so we're still building our buffer up. So we're adding onto our buffer our target ret, so our return address, and then basically we're converting it into Little Indian format here. On top of that, we're adding our 20 NOPs, and then we're basically encoding our payload. So our payload is basically what we define inside of Metasploit to use as a payload. So what this allows us to use different payloads. So if we don't want to use Meterpreter, we can, but you can basically choose just a standard reverse shell, a bind shell, things like that to test and use here. So once again, we're not hard coding our payload into the code. We're allowing for the flexibility to define it within Metasploit. Once we have our buffer created, we're going to basically connect. So that connect function is basically calling that MSF exploit remote TCP and is using the defined R host and R port that we're defining in our Metasploit setup. And it's going to try to connect. It's going to wait about 15 seconds. If it does connect after 15 seconds, it's going to error out. If it connects, then basically we're going to do a sock get. So we're going to get. So basically we're going to get any messages back from the machine. And then basically we're going to launch our handler. If there's an error, we'll basically have a little error catching here for rescue. And basically what this rescue is doing is if the host is not reachable, if the connection is timed out, if the connection is refused, or we get our timeout error with our connection, basically it will exit the program gracefully. So basically you'll get a message back to your screen that says, exploit ran successfully, but no shell. So basically it went through the whole process, no problems, and it gave you a reverse shell. Now we can modify under rescue to get more details where it failed, but that's up to you to decide if you want to go that route. So very simplistic. It's a very simple exploit. I figured it'd be very easy to port over to show you guys how to do this so you guys can get some ideas if you want to try this out yourself. If you have any questions about developing the exploit, let me know. Put it down in the comments. Let me know what exploits you tried porting over before and if they were successful or not. Or if you see another exploit that's kind of similar that you'd like to see ported over, let me know. Maybe I could take that as a challenge once I'm done studying for my exams. So at this point, let's save this, right? And once we save this, what we want to do next is we want to copy this over into our Metasploit framework. So if we do user/share Metasploit framework, modules, exploit Linux MISC. The reason we're putting into the Linux MISC is, first of all, it's Linux, and second of all, it's not a web exploit. It's not a it doesn't have a defined program, and it's not really ever going to be used outside of VulnHub. So I decided to put it in the MISC folder. If you develop the exploit for a different function, put it into the proper folders. If you actually come over here, and we'll do an ls of this directory, you can see some of the layouts here. So you can do antivirus attacks, browser, FTP, games, HTTP, so on and so forth, right? But we're just using MISC here. So once that's inside our framework, right, all we're going to do is come over to our Metasploit, and we're going to do use exploit Linux MISC Brainpan 2, and now we have our Brainpan show info. Yep, show info. Sorry. You can see the information that's inside that template. So name, Super Kojimon, Brainpan, prone to own remote buffer overflow, exploit/MISC/Brainpan2 is the module. Platform is Linux, no architecture defined. License Metasploit Framework. Rank is normal. I probably could put excellent here because it works every single time. Provided by Michael Salvi, aka GenXWeb. System or software version, didn't really provide that, so no problem. Check support, I probably should change this to no because you can't run a check because I didn't find the check function. So it'll run, but it won't come back with anything. And then basically the two things you need to provide this script is your R host and your R port for this to work. And then payload information avoid 1 characters, and basically that characters is the /x00. No CVEs defined, but you can go out to my URL digitaloffensive.com, right? So we're going to do set our host 192.168.1.32, and I spelled set wrong. So we're going to do set our port 9999, set lhost. The only reason I'm setting lhost is because I have multiple interfaces on this box, and it may go to the wrong interface. I'm going to not set the L port, even though you know I like to set 443. I just want to show you that you don't have to define that for this Metasploit module to work. And the last thing we're going to do here is we're going to define our payload as reverse Linux. Now, in theory, we already crashed Brainpan. Brainpan has a script that should restart the service. So let's just quickly verify that the service is still up. Okay, we see port 9999 is open, so we know Brainpan's back up and listening. We have our TCP dump going. Now, when we run this module, I want you to see something cool here. You see here we have all our A's, right? What you're going to see here is just a random buffer. So we're going to come back over here. We're going to type in exploit. We got our interpreter shell. And you can see that we're user puck and hostname is Brainpan. So our interpreter module worked, or our Metasploit module worked. Now we come back over to our buffer overflow, our TCP dump of it, and we come over here. We see the banner for Brainpan, right? Welcome to Brainpan. Enter your password, and boom, we got all randomness. So kind of hiding our buffer. Then we come down. So all randomness, then we come down to our NOP sled, and then our interpreter payload right here, from here down. So guys, I hope you enjoyed this video. Any questions, comments, feel free to put them below. Once studying's done, my test is next Friday. Hopefully I'll be able to get you guys out a lot more videos. Once again, if you're new to this channel, make sure you subscribe and click the bell to be notified when new videos come up. If you like this video, make sure you give it a thumbs up, guys. All the thumbs ups and comments really help the channel grow. So the more love you give, the more love I get, and the more I can get out to you guys. Once again, thank you for watching this video. Leave your comments below. Have a good day.